Okay, for any data that is that we know is normally distributed, we can create our normal bell-shaped curve for that particular data. And again, like I said, we know that the mean goes right down the middle of that particular data. One other thing we know from the empirical rule, and I think it was from a previous chapter, it might be just from here in this chapter on page 248, that when data is normally distributed, we know that if we go out one standard deviation each way, okay, so if we take our mean and we add one standard deviation and we subtract one standard deviation, okay, that about 68% of the values fall within one standard deviation. Okay, so we also know that if we go out two standard deviations, we add another standard deviation this way and we subtract another standard deviation this way, then we know that about 95% of our data fall within two standard deviations of the mean. And then if we were to go out three standard deviations each way, so we got a third standard deviation here and a third standard deviation here, then we know that about 99.7% of our data fall within three standard deviations. Now this is true for all normally distributed data. So we're able to take any data regardless of what the mean and the standard deviation are and create them in what's called the standardized normal distribution. So let's just take this same kind of example here. And if we've got our normal distribution, and let's say that this data has a mean of 100 and a standard deviation of 10. So we know that our mean goes right down the middle at 100. And if we go up one standard deviation and down one standard deviation, we know that this would go up to 110 because you take your mean plus a standard deviation. And this would go down to 90 because we take 100 minus 10, one standard deviation. And that would be the area for one standard deviation. And again, according to the empirical rule, we know that it's about 68% of our data then would fall between the values of 90 and 110. And if we go out two standard deviations, we go down to 80 and up to 120. Again, we would know that about 95% of our data would fall within two standard deviations. And then if we go out three standard deviations, down to 70, up to 130, we'd know that about 99.7% of our data would fall within three standard deviations. Now, standardized normal form tells you that no matter what your mean is, these are all x values. Okay, these are all. And no matter what your mean is in terms of an x value, we're going to convert that into a z value of 0. So it doesn't matter if you have a mean of 100 or a mean of 1,000 or a mean of 10,000 or a mean of 0.5. Whatever your mean is going to be assigned a z value of 0. Okay, and whatever the value for one standard deviation is will be assigned z values of 1 and -1. And wherever two standard deviations falls will be assigned values of 2 and -2. And wherever 3 is will be assigned z values of 3 and -3. So this is your standard normal probability distribution where you take your actual values, your x values, no matter what they are, and you can convert them into z values. Meaning wherever your mean is, it has a z value of 0, one standard deviation is 1 and -1, two standard deviations 2 and -2, and three standard deviations is 3 and -3. So I'm going to stop there and we'll start the next video.